Sorry, this is a continuation of part 5. My device just got a small problem, so I'm just continuing. This is supposed to be a continuation of part 5. I wanted part 5 to be 1, but the device got a small snap and it went off. So let me just continue from here. So the work done, W is going to be equal to the work done W, because we want what is the minimum work done here. So the work done is going to simply be equal to the gain in potential energy. Why? If we assume that there is no loss in energy, or if we assume that there is no frictional force, then we can assume that there is no loss in energy. Then it means the work done should be equal to the gain in potential energy. So this means the work done should be equal to 50 or mg times h. So this means this is going to be equal to 50 times g, which is 9.81, then times the height, which is 1.6. So this is going to simply be equal to 50 times 9.81 times 1.6, which gives us 784.8 joules. So if that is going to be the minimum energy. If this is going to be the minimum work done. So if there is a friction, then it means the work done must be above this, but this is going to be the minimum. So the answer is going to be C. For minimum, we assume that no work is done against resistance. But if there is also some work to be done against the resistance, then the work must be greater than 780 joules. A concrete cube of side 0.5 meters and uniform density 2.0 times 10 power 3 kilograms per meters cubed is lifted 3 meters vertically by a crane. What is the change in potential energy of the cube? So we want change in potential energy. So potential energy or change in potential energy is simply going to be mg times the change in the height h. But we don't have the mass, we have the density and that length. The mass is going to be density times volume, so this will be times g times h. So this will therefore be equal to the density. What is the change in potential energy of the cube? It is a cube where all sides are going to be equal, so this will be just simply 2 times 10 power 3 for density, then times the volume, which is 0.5 raised to power 3 because it is a cube, times g, which is 9.81, times h, which is 3. So 2 exponent 3 times 0.5 cubed times 9.81 times 3. So this is giving us 7357.5. 7357.5, which is approximately 7.4 kilojoules. So I move 3 steps to, I divide by 1,000 to change it to kilo. So the answer is going to be 7.4 kilojoules. What is the internal energy of an object? I said internal energy is in air level, temperature, ideal gases, thermodynamics. That's where you find internal energy. But we can still answer this. Remember, it is the sum of the random distribution of the potential and the kinetic energy of all the molecules that make up a system. For those who have studied the air level, temperature, ideal gases, and thermal properties, you have seen this. So the answer is automatically D. It is the sum of all the microscopic potential and kinetic energies of the molecules. A motorist traveling at 10 meters per second can bring his car to rest in a braking distance of 10 meters. In what distance could he bring the car to rest from a speed of 30 meters per second using the same braking force? If he's using the same braking force for the same car, it means the acceleration is going to be the same. Let's first find the acceleration. So by using v squared is equal to u squared plus 2as. Because it comes to rest, v is 0, so 0 squared is going to be 30 squared, and this will be plus 2 times the acceleration times The distance initially is 10. The braking distance is 10. So that means the acceleration is going to be negative. So I'll say 30 squared. Of course, it is negative. When I take 30 squared on the left-hand side, it is negative. Divide by 20. So that is going to be negative 30 squared divided by, is it 20? Yes, 30 squared divided by 20. No, it is not 30, it is 10. So 0 squared is equal to 10 squared plus 2a times 10 times 10. So it means it is 100 divided by 20 negative, which gives us negative 5 meters per second squared. That is the acceleration. It is negative because we are applying a braking force. So the question is, in what distance could he bring the car to rest? That means again final velocity is going to be 0 squared, but it's coming from a speed of 30, so this is squared, plus 2 times negative 5. Because using the same braking force, it means the resultant force is the same, so the acceleration is going to be the same, or the deceleration. So this is negative 5, then times the distance. I'll just call it d. So this would be times d. So making this the subject means d is going to be equal to negative 30 squared divided by negative 10. And I think this is 90. Because it is 900 over 10, which is 90. So the answer is going to be D. A stone of weight 4 newtons in the Earth's gravitational field is moved from P to Q and then to R along the path. How much potential energy does the stone gain? Of course, because it's moving the Earth's gravitational field, the gravitational field acts vertically downwards. So we are just considering the weight being overcome in the vertical. So the work done is going to be equal to the gain in potential energy, which is simply going to be mg times h. So the mass is, mg is going to be 4.0, and then the height is going to be 30. We shall ignore 40, we shall ignore 50, we shall only take 30, which gives us 120 joules. So the answer is going to be A. Which expression defines power? Force times distance. We know power is the rate of doing work, so it is work done over time taken without wasting time. The total energy input in a process is partly transferred to useful energy output U, and partly to energy that is wasted W. So energy input is E in, useful output is U. Efficiency is equal to the useful energy output, which is U, over total energy input, which is E in. So our answer is going to be automatically B. Is it B? No, it is not B. U over E in, that is C, times 100 to change it to a percentage, so it is times 100%. The diagram shows two identical vessels, X and Y, connected by a short pipe with a tap. Okay. Initially, X is filled with water. Initially, X is filled with water of mass m to a depth h, and Y is empty. When the tap is opened, water flows from X to Y until the depths of water in both vessels are equal. So let's say, of course, if the depths in both are equal, it means half of the mass here has gone away. So what the mass remaining here is going to be a half m, and the mass here is also going to be a half m. How much potential energy is lost? How much potential energy is lost by the water during this process? How much potential energy is lost by the water during this process? So the mass which remains is a half m, and of course the height is going to be a half h. The height is going to be a half h. So the change in potential energy is going to be mg times the change in height. So the mass which has been lost is a half m, then times g, then times the height which is there is a half h. So this gives us a quarter mgh. So So the answer is mgh over 4. So the answer is automatically going to be B. mgh over 4. So that is automatically B. Which of the following is an expression for power? An expression is just not, it's not a definition, but expression. So power is energy over time, not energy times time. Power is force times velocity, not mass times velocity. So the answer is going to be C. A car driver adjusts the pressure on a car's brakes so that the car travels at constant speed down a hill from P to Q. The magnitude of the change in the car's kinetic energy is delta Ek. The magnitude of the change in its gravitational potential energy is delta Ep. Which statement is correct? They said the car travels at a constant speed. That means there is no change in kinetic energy. So change in kinetic energy is 0. So the question is asking which statement is correct. A car driver adjusts the pressure on a car's brakes so that the car travels at constant speed down a hill. The magnitude of the change in the car's kinetic energy is 0. The magnitude of the change in its gravitational potential energy is delta Ep. Which statement is correct? The change in kinetic energy is equal to the change in potential energy. So this one is not correct. Because there is no change, it is traveling at a constant speed, the change in kinetic energy is 0. So the answer is automatically D. An area of land is an average of 2 meters below sea level. To prevent flooding, pumps are used to lift rainwater up to sea level. What is the minimum pump output power required to deal with 1.3 times 10 power 9 kilograms of rain per day? So we know that power is going to be equal to the work done over time taken. So we're going to lift 1.3 times 10 power 9 kilograms of rain per day. So this is going to be mgh divided by T. So the mass is 1.3 times 10 power 9. G is 9.81 and h is going to be 2.0 meters. Time is 1 day, which one day is 24 hours times 3,600. So we have 1.3 exponent 9 times 9.81 times 2.0 divided by 24 times 3,600, which gives us 295,000, approximately 295,000, which is, so this is approximately 295,000, which is approximately 300,000, which is 300 kilowatts. So the answer is going to be D. A twig from a tree drops from a 200-meter high cliff onto a beach below. During its fall, 40% of the twig's energy is converted into thermal energy. What is the speed with which the twig hits the beach? 40% is converted into thermal energy. That means it is only 60% which becomes kinetic energy. So 60% becomes kinetic energy. 60% becomes kinetic energy. So let's see. So 60% of the loss in potential energy becomes kinetic energy. So the loss, or let's say the kinetic energy is going to be equal to 60% of the loss in potential energy. So kinetic energy is going to be a half mv squared is going to be equal to 0.6 times mgh. So m has cancelled. We want v. So v is going to be the square root of 0.6 times 9.81 times height, which is 200, divide by, there is times 2. I'm making V the subject, so that is fine. So I have 0.6 times 9.81 times 200 times 2. Then find the square root. What have I done? 0.6 times 9.81 times 200 times 2, square root of the answer. So that is 48.5. So V is going to be 48.5 meters per second. So my answer is going to be approximately 49. So note very carefully, they told us 40% is converted to thermal. So it means it is only 60% which becomes kinetic energy. So 60% of the loss in potential energy becomes kinetic energy. The 40% is wasted. A mass is raised vertically. In time t, the increase in its gravitational potential energy is EP, and the increase in its kinetic energy is EK. What is the average power input to the mass? What is the average power input to the mass? Okay, so we know that potential and power is going to be equal to the energy over time. Energy should be total energy. So this is going to be total energy, which is potential plus kinetic, then divided by time. So our answer is automatically going to be D. The average power input to the mass is going to be the potential energy it gains and the kinetic energy it gains, which is going to be equal to EP plus EK divided by T. A boat moving at constant speed v through still water experiences a total friction drag F. What is the power developed by the boat? What is the power developed by the boat? So we know that power is simply force times velocity, so the answer is B. The kinetic energy of a particle is increased by a factor of 4. By what factor does its speed increase? We have answered this question. Let's say initially kinetic energy is equal to a half mv squared. Then now it is increased by a factor of 4. So 4 times Ek should be equal to a half m times the new velocity, which I'm going to call v2 squared. So let's divide the two equations. We have 4 Ek over Ek is equal to a half m has cancelled. So we remain with the v2 squared over v squared. So Ek has also cancelled. So it means v2 squared is going to simply be equal to 4 times v squared. When I find the square root, it means that v2 is going to be 2 times v. So the speed increases by a factor of 2. A horizontal force of 90 newtons is used to push a box across a horizontal floor. The frictional force on the box is 50 newtons. What is the gain in kinetic energy of the box? What is the gain in the kinetic energy of the box when it is moved through a distance of 6 meters? So the work done, or the change in the work done, or the work done must be equal to the change in kinetic energy. And the frictional force on the box is 50 newtons. The frictional force on the box is 50 newtons. So we just look for which force causes a change in kinetic energy. So, or alternatively, I can say work done by the force of 90 newtons is equal to the gain in kinetic energy plus the work done against friction. So the work done, total work done by the force of 90 is equal to change in kinetic energy plus the work done against friction. So that means I can say 90 times the distance of 6 should be equal to change in kinetic energy plus 50 times the distance of 6. So which is the same as saying that the change in kinetic energy, or the gain in kinetic energy, is going to be 90 minus 50 then times 6, which gives us 40 times 6, which is 240. So this is 240 joules, which makes the answer to be A. A cyclist is capable of generating an average power of 3 kilowatts during a 4-kilometer speed trial. His aerodynamic suit and position on the cycle reduce resistive forces to 180 newtons. What is the approximate time achieved in the speed trial? Of course, we know that power is equal to energy over time. This is simply going to be work done divided by time. So the power is 3000. The work done is going to be his aerodynamic suit and position on the cycle reduces resistive force to 180. So the force is going to be 180 because work done, this is going to be force times distance over time. So this is going to be force, which is 180 times the distance, which is 4,000 meters divided by the time. So I'll just make T the subject. So I have 180 times 4,000 divided by 3,000, which gives us 200. So the time here is 240 seconds. So the answer is going to be B. This is 180. A constant force 9 kilonewtons parallel to an inclined plane moves a body of weight 2 kilonewtons through a distance 40 meters along the plane at constant speed. Not very well at constant speed. The body gains 12 meters in height as shown. How much of the work done is dissipated as heat? How much of the work done is dissipated as heat? So the total work done, or the work done, must be equal to, okay, let's first find gravitational potential energy. How much of the work done is dissipated as heat? So a constant force of 9 kilonewtons parallel to an inclined plane moves a body of weight 20 kilonewtons through a distance of 40 meters along the plane at constant speed. The body gains 12 meters in height as shown. So let's first find the gain in potential energy. Gain in potential energy is mgh, which is going to be mg is the weight is 20 kilonewtons, so mg is going to be 20,000 times h, which is 12. That is the mg, that is the gain in potential energy. But the total work done is equal to force times the distance moved along the plane, where the force applied is 90,000 times the distance, which is 40 along the plane. If the work done along the plane is not equal to the gain in potential energy, then some of it is wasted to overcome friction. So the work dissipated. The work dissipated will therefore be the difference between these two. It will be 90,000 times 40 minus 20,000 times 12. So this is going to be equal to 90,000 times 40 minus 20,000 times 12. So this is giving me 3, that is 3, oh, sorry, this is 9,000, not 90. I think I'm absent-minded, I'm very tired. So this is 9,000, not 90, it is 9,000. So let me check again. 9,000 times 40 minus 20,000 times 12. So I'm getting 120,000. So this is 120,000 joules, which is 120 kilojoules. So the answer is A. To get to his office from the entrance of the building, a man has to walk up 6 feet of stairs. The height of each flight is 2.5 meters, and the man has a mass of 80 kilograms. What is the approximate gain in the man's gravitational potential energy? So that will be equal to simple work done. So the gain in the gravitational potential energy will simply be equal to the work done, which will be force times distance, or it will simply be mg times h. mg times h. So m is 80, g is 9.81, and h, there are six flights of stairs, each of 2.5, so it will be 6 times 2.5. So this will be 80 times 9.81 times 6 times 2.5, which gives us 11772. 11772 joules. So this is the same as 1000, that is 11,000, which can be 12,000 joules. So this means our answer is going to be D, 12,000 joules, to two significant figures. In many old style filament lamps, as much as 93 joules of energy is emitted as thermal energy for every 7 joules of energy emitted as light. What is the efficiency of the lamp as the percentage of electrical energy converted to light energy? We want efficiency. So we know that efficiency is equal to output over input times 100. So efficiency will be equal to the output, which is 7 joules, over as much as 93 joules of energy is emitted as thermal and 7 as light. So total is 93 plus 7, which is 100. Then we multiply this by 100, so this gives us 7%. So this is 7%, because total energy is 93 plus 7 joules, so which is 100. So the answer is going to be A, 7%. An electric railway locomotive has a maximum mechanical output of 4 megawatts. Electrical power is delivered at 25 kilovolts from overhead wires. The overall efficiency of the locomotive in converting electrical power to mechanical power is 80%. What is the current from the overhead wires when the locomotive is operating to its maximum power? So we know that efficiency, which is 0.80% or 80%, should be equal to the output power, which is 4 times 10 power 6, over the input, which remember power is equal to I times V. So the input is going to be I times V, where V is 25,000, then times I. So I want I. Making I the subject, I'll have 4 exponent 6 divided by 25,000, again divided by 0.8. I'm making I the subject, so this is 200. So this means I is equal to 200 amperes. So the answer is C. A car of mass 100 kilograms first travels 25 meters per second and then forwards 25 meters per second, and then backwards at 5 meters per second. What is the change in the kinetic energy? Of course, energy is a scalar quantity. So initial kinetic energy. So I'm finding the change in kinetic energy. So I can subtract kinetic energies, but remember energy is a scalar quantity. So initial change in kinetic energy is going to be a half times the mass, which is 1000. I will not put a minus on 5 meters per second, even if it is moving backwards, because I'm dealing with kinetic energy, which is a scalar, but I can get differences in energies or in kinetic energies. So initially I have a half times 1000 times 25 squared, and finally, so I will then subtract the other energy, which is a half times 1000 times 5 squared, which gives me, so I'll just simply say 500, that is a half of 1000 times 25 squared, minus again 500 times 5 squared, which is giving me 300,000. So this is 300,000 joules. So that is 300 kilojoules. When bungee jumping, a student starts with maximum gravitational potential energy at, that is position 1. then folds freely until the rope fully unwinds, position 2, after which the rope starts to stretch until the lowest point of the jump is reached, position 3. So position 2, the rope has fully unwinded but has not started stretching. Position 3 stretches up to position 3. What are the kinetic and elastic potential energies at position 3? So at position 3, the elastic potential energy must be maximum at position 3 because the rope is fully stretched, so I ignore minimum. But then the kinetic energy, because at position 3 comes to rest, then the kinetic energy becomes minimum. So it means because when the rope is stretching as the rope stretches, as the elastic potential energy increases, the kinetic energy is decreased. So the kinetic energy is going to be minimum. So the answer is going to be minimum kinetic energy and maximum elastic potential energy. Maximum elastic potential energy, because elastic potential energy is equal to a half kx squared. As the rope stretches to a maximum point, the elastic potential energy becomes maximum. But as the rope stretches, the child slows down. That means the kinetic energy decreases. That's why velocity becomes minimum, so the kinetic energy becomes minimum. So the answer is C. A block of weight W is pulled up a rough slope by force F. When the block has moved a distance x along the slope, it has risen height h. Which expressions give the amount of work done on the block and the amount of gravitational potential energy gained by the block? Amount of work done on the block and the amount of gravitational potential energy gained by the block. For potential energy, it is mg times h, where m is weight, so it is wh. Potential energy is wh, so it is not wx, it is not fh, it is not fx, so the answer is automatically A. Of course, work done is force times distance in the same direction, so it is F times x, so the answer is automatically A. A pendulum bob oscillates between P and R. Assume that the gravitational potential energy lost in moving from P to Q is converted into kinetic energy. What is the speed of the bob at Q? Of course, at Q, the speed must be maximum. They are saying assuming that the gravitational potential energy lost at P, from P to Q, is converted into kinetic energy. So potential energy is going to be, the loss in potential energy is going to be M. What is wrong with this pen? mgh. It is actually going to be mg times y. And this should become kinetic energy, which is a half mv squared. So m cancels. I'm taking this part alone. M cancels, making v the subject. V is going to be twice gy. Then I find the square root. So the answer is going to be C. Which operation involves the greatest mean power? Greatest mean power. Of course, we know power can be force times velocity. Let's check this one. 0.4, the greatest average power. 0.4 times 1000 times 20. That is, this one is giving us 8000 watts. And this one is giving us, of course, this one will give us 6000 watts. And this one will give us 5000 watts. A weight being pulled across a horizontal surface at a speed of 6 against a frictional force of 1.5 kilonewtons. It is, of course, it is being pulled at a constant speed of 6. So the weight should be equal to the frictional force. So I would simply say 1.5 times 1000 times 6, which is giving me 9000. So this one is 9000 watts. So it means our answer is going to be D. The answer is going to be D. And lastly, in work, energy and power, an electrical railway locomotive has maximum mechanical output 4 megawatts. We have done this equation. Electrical power is delivered at 25 kilovolts from overhead wires. The overall efficiency in converting electrical power to mechanical is 80%. So the efficiency is 0.80. Power output is 4 times 10 power 6 because efficiency is the power output over power input. We said power input can be I times V. So this would be 25,000 V, then times the current I. We want to find the current. So we say this will be making I the subject for exponent 6 divided by 25,000 divided by 0.8, which is 200. So I was 200 amperes. So that marks the end of work, energy, and power. If I get time, I'll now record force, density, and pressure. Thank you. Bye-bye.